Shell sort is a highly efficient sorting algorithm and is based on insertion sort algorithm. This algorithm avoids large shift as in case of insertion sort. If the smaller value is to the far right and has to be moved to the far left. Shell sort is a generalized version of the insertion sort algorithm. It first sorts elements that are far apart from each other and successively reduce the interval between the elements to be sorted. The interval between the elements is reduced based on the sequence used.
The shell sort, or also known as Shell's method, is named after its inventor, Donald Shell, who published this sort algorithm in 1959. This is a sorting algorithm that he made to be applied to a set of order to sort it.
Something about the shell sort. Did you know that the other name for a shell sort algorithm is diminishing decrement sort? As the distance between comparisons decreases as the algorithm runs until the last piece. Shell sort is invented by Donald L. Shell at the year of 1959, about 2 years before Harris Pitt sort. It is an extension of the infamous bubble sort, but instead of comparing and exchanging, if need be, only immediately neighboring cells, it relies on an increment sequence to compare and exchange cells that are farther apart and eventually sort of the array. Shell sort is widely used because it improves its time complexity by taking the advantage of the fact that using insertion sort on a partially sorted array results in less number of moves.
Here are the advantages of shell sort. With improved average time complexity, it is a very efficient algorithm for medium-sized arrays. In terms of shell sort, meron siyang average time complexity. Kapag sinabi kasi nating average, meron siyang tamang bilis, at kapag sinabi naman nating time complexity, ito yung amount ng time na tinetake ng isang algorithm para mag-run. Since ang shell sort ay mayroong average time complexity, sobrang efficient niyang gamitin para sa medium-sized arrays. Next, it is better than insertion sort and 5 times faster than bubble sort. Kasi nga, ang shell sort ay ang improved algorithm ng insertion. At ito ang pinaka-basis niya. Kaya masasabi na mas efficient itong gamitin since ito na yung upgraded or sabihin na nating improved type ng insertion. So, ang shell sort is 5 times faster than bubble sort. It is because ang algorithm na bubble sort ay di ganun kabilis and kaya lamang nito mag-move ng item by one position. Unlike the shell sort na pwedeng mag-relocate ng kahit anong item sa kahit anong position just by swapping places.
Kung may advantage, meron din disadvantage ang shell sort. Papaliwanag ko ang disadvantage ng shell sort. Ang disadvantage is, it is a complex algorithm, not that efficient as merge sort and quick sort. Also, it is limited to use for small size arrays as the performance decreases with an increase in array size. So, ibig sabihin, komplikado ito kumpara sa ibang algorithm. Not that efficient as merge sort and quick sort. Limitado ang paggamit nito para sa size ng isang array, bumababa o nagde-decrease ang performance kasabay ng pagtaas o pag-increase ng array size. So, meron din kahinaan o disadvantage ang shell sort.
Dumako naman tayo ngayon sa algorithm. Dito sa algorithm, ipapakita natin kung paano nasosort ang elements using the shell sorting. Para mas madali nating maintindihan, meron akong inihanda ditong example. Meron tayo ditong 8 cards of diamonds dito sa ating harapan in any order. Para masort natin sila in ascending order, kailangan natin sundin ang step-by-step ng shell sorting algorithm. Step 1. Initialize the value of h. So, ibig sabihin ng h natin is the interval with initial value of 1. So, dito sa ating 8 cards of diamond, ang interval with initial value natin ng 1 is ito. So, proceed na tayo sa step 2, which is to divide the list into smaller sublists of equal interval h. So, itong 1, 2, 3, 4, 5, 6, 7, 8 na card natin is i-divide natin yan sa smaller sublist of equal interval ng h. Hindi naman natin pwedeng i-divide ang 1 dahil 8 pa din ang lalabas. So, jump na tayo sa 2. So, 8 divided by 2 is 4. So, ang gagawin nating interval is 4. So, magsisimula tayo dito. Then, dito na tayo magka-count. Mag-start ng count. 1, 2, 3, 4. Para malaman natin kung magsaswap sila ng position, is lahat ng nandito sa 5 papunta dito sa left ay kailangan mas malaki kaysa dito sa 4 papunta dito sa 3 or sa right. So 2 and 4, mas malaki pa din tong 4 kaysa sa 2, so hindi sila magpapalit. Dito naman tayo sa kasunod at ang interval din nila is 4, which is 1, 2, 3, and 4. Yan. 7 and 1, mas malaki na tong nandito sa left kaysa sa right. So, mag-switch na silang dalawa. And ito namang 6 and 8, mas malaki naman tong nandito sa right kaysa sa left. So, hindi sila magpapalit. And ito namang kasunod, 5 and 3, mas malaki tong nasa left kaysa sa right. So, magpapalit sila. So, nag-proceed na tayo sa step 3, which is the sublist using insertion sort. So, sa step 4 naman, is repeat until complete list is sorted. So, dito naman, kahit hindi ka na mag-interval, kahit yung katabi na lang yung pagsaswapin mo. Para makuha natin yung ascending order ng ating hinahanap. So, itong 2 and 1, mas malaki itong nasa left kaysa sa right. So, mag-switch sila. Ito namang 2 and 6, dahil mas malaki pa din itong nasa right kaysa nasa left, dito pa rin sila. Ito namang 6 and 3 is mas malaki itong nasa left kaysa sa right. So, mag-switch na sila. And ito namang si 4 and si 6, mas malaki pa din tong nasa left, so magsi-switch sila. Then ito namang si 6 and 7, mas malaki tong nasa right kaysa sa left, so hindi sila magsi-switch. And ito namang si 7 at si 8, hindi din natin sila pagpapalitin dahil mas malaki tong nasa right kaysa nasa left. And ito namang si 8 and si 5, pagpapalitin natin dahil mas mataas tong nasa left kaysa nasa right. Then si 5 at saka si 5 at si 7 is pagpapalitin natin dahil mas malaki itong nasa left kaysa nasa right. Lastly, pagpapalitin naman natin itong si 6 and si 5 dahil mas mataas itong nandito sa left kaysa sa right. And there you have it. Nagawa na natin ang shell sorting algorithm using the step-by-step.
Now, let's move on to the pseudocode. First, rearrange element at each n divided by 2, n divided by 4, n divided by 8, and so on intervals. Void sorting. Initialize int array int n. First loop, 4 int interval equals to n divided by 2, interval greater than 0, and divide interval by 2. Second loop, 4 int I is equal to interval I less than n, I increment 1. Next is select value to be inserted. Initialize int temp is equal to array I, which is the interval, int j. Third loop, for j is equal to I, j greater than equal interval, and array j minus interval greater than temp, and j decrement interval. Array j is equal to array j minus interval. Insert the number at the whole position. Array J is equal to temp.
To test the pseudocode, here are the sample program for shell sort algorithm. First, we declare an array and its elements to be sorted. For this example, we have 9, 8, 3, 7, 5, 6, 4, 1, and 2. Next, we declare an initialized variable which is the size that can hold the elements in the array. Next, to display the unsorted element, we use looping. After that, in order to sort the array elements, we will use the sorting class. In this case, it will sort the elements according to the process on the program above, which is the shell sort algorithm. Finally, the output would be displayed the unsorted and sorted elements using shell sort.